The research investigates whether large language models, LLMs, truly adapt to domains and consistently reason over semantic relationships between concepts, or if they primarily leverage lexical senses and their frames. To answer this, a controlled experiment was designed using WordNet to synthesize parallel corpora, including English and gibberish terms. The study examines the differences in LLM outputs for each corpus in two ontology learning tasks: relation extraction and taxonomy discovery. The results show that while adapting to gibberish corpora, off-the-shelf LLMs do not consistently reason over semantic relationships, instead relying on senses and their frames. However, fine-tuning improves LLM performance on lexical semantic tasks, even with domain-specific terms unseen during pre-training, suggesting the applicability of pre-trained LLMs for OL. The study highlights the challenges of LLMs, including susceptibility to hallucination and limited generalizability to unknown domains, emphasizing the need for further research on these aspects. The paper investigates the generalizability and domain adaptability of large language models, LLMs, from an ontology learning perspective. It presents comprehensive experiments on popular LLMs, including closed and open-source models, to assess their performance on relation extraction and taxonomy discovery tasks. The study creates 3 synthetic datasets by turning domain-specific terms into gibberish, simulating the adaptability and generalizability of LLMs in unseen domains. The results show that there is a limit to the generalization capability of off-the-shelf LLMs, especially for tasks that leverage lexical semantics. However, in-domain fine-tuning improves in-domain task-specific performance, and these improvements are transferable to new domains. The paper also discusses related works in ontology learning with LLMs, in-context learning, and domain adaptation, highlighting the significance of fine-tuning and the limitations of off-the-shelf models. Here is a combined summary of pages 5 and 6 of the research paper. The authors investigate the adaptability of large language models, LLMs, to specific domains from an ontology learning perspective. They propose an evaluation pipeline that involves corpus preparation and LLM evaluation. The pipeline begins with the creation of a parallel corpus of terms and definitions in the form of gibberish, which serves as a reference domain-specific setting. This is achieved by using the English WordNet to generate a parallel corpus of concepts and definitions, where the concepts remain the same up to an input label mapping. The authors then evaluate the LLM on 2 tasks: relation extraction and taxonomy discovery, each on both versions of the corpus. They expect the results to be analogous since the concepts remain the same. Additionally, they investigate the effect of fine-tuning on the in-domain performance of LLMs. To simulate a domain that is unseen for the LLM, the authors generate another knowledge graph where the domain concepts have gibberish representations and definitions that do not collide. This is achieved through a 3-step procedure: concept mining, concept linking, and gibberish generation. The concept mining algorithm is a simple breadth-first search algorithm that explores concepts through user-selected relationships. The concept linking step establishes dependencies between concept definitions and other concepts, and the gibberish generation step creates a gibberish representation and definition for each concept. The authors use this pipeline to test the adaptability and generalizability of off-the-shelf LLMs, and to investigate the effect of fine-tuning on their performance. The results of this evaluation will provide insights into the ability of LLMs to adapt to specific domains and perform well on unseen data. The paper discusses the adaptation of large language models, LLMs, to domains from an ontology learning perspective. It presents a novel approach to evaluate LLMs' ability to adapt to new domains by creating gibberish representations and definitions for concepts within a domain. This is achieved through an algorithm that propagates gibberish representations and definitions across concepts, resolving dependencies as it goes. The authors also propose an off-the-shelf evaluation methodology for assessing LLMs' performance in 2 lexical semantic tasks: relation extraction and taxonomy discovery. In these tasks, the LLMs are prompted to extract relations between concepts or determine subclass relationships, respectively, using both the original dataset and its gibberish counterpart. The performance of the LLMs is then compared across these 2 cases to determine if they truly adapt to the new domain or simply rely on lexical senses. The paper provides examples of how this methodology can be applied, including prompts for relation extraction and taxonomy discovery tasks. It also highlights the importance of using WordNet hypernymy relations as a ground truth for evaluating the accuracy of the LLMs predictions in the taxonomy discovery task. Overall, the paper presents a unique approach to evaluating LLMs' domain adaptation capabilities and provides insights into their ability to learn and apply semantic information from textual data. This research has implications for improving the performance of LLMs in various natural language processing tasks and understanding their limitations in adapting to new domains. Here is a combined summary of pages 9 and 10 of the research paper. The authors investigate whether large language models, LLMs, can adapt to arbitrary domains and unknown vocabularies, focusing on ontology learning. They propose fine-tuning experiments to assess the effect of fine-tuning models on inference performance for taxonomy discovery tasks. The fine-tuning experiment involves training LLMs on instructive datasets with a prefix prompt, where the model is asked to identify whether a statement is true or false, given a pair of concepts and their definitions. The authors generate 3 synthetic domain-specific datasets from the Open English WordNet, namely suites, football, and music, to assess the performance variation with domain specificity. These datasets are characterized by their number of concepts, hypernymy relationships, exploration depth, and root concepts, as shown in Table 1. The datasets are used to evaluate the performance of popular LLMs, including GPT-3.5, GPT-4, Falcon 40B, and others, in both off-the-shelf and fine-tuned settings. The fine-tuning experiment involves training LLMs on a trained split of hypernymy relations, using half of the concepts in the dataset and their hypernymy relations, alongside some randomly sampled negatives. The remaining relations are used for testing. The authors use a prefix prompt, as shown in listing 1.4, to instruct the model to identify whether a statement is true or false, given a pair of concepts and their definitions. The authors aim to explore the trend between LLMs in adapting to arbitrary domains and unknown vocabularies, and to verify whether fine-tuning improves ontology learning performance in these domains. The results of the experiments will provide insights into the ability of LLMs to adapt to new domains and vocabularies, and the effectiveness of fine-tuning in improving their performance. The paper discusses the adaptability of large language models, LLMs, to different domains, focusing on their performance in ontology learning tasks. It evaluates several LLMs, including GPT-3.5, GPT-4, Falcon 40B, Llama 213B, and Zephyr 7B beta, using both real and gibberish datasets for relation extraction and taxonomy discovery tasks. The results show a significant performance decrease when replacing real terms with gibberish in both tasks. For instance, in the relation extraction task, GPT 3.5 feed-S macro F1 score drops from 0.228 to 0.115 when using the gibberish dataset instead of the real one. Similarly, in the taxonomy discovery task, GPT-3.5's F1 score drops from 0.940 to 0.446 when switching to the gibberish dataset. This performance drop suggests that LLMs are better at leveraging semantic priors, or lexical senses known from pre-training, to deduce hierarchical relationships between concepts. However, they struggle with unknown words that share the same semantic relations, indicating a lack of adaptability to new domains. The study also highlights the importance of considering the completeness and quality of the ground truth datasets, as the English WordNet is found to be scarcely annotated in terms of hypernymy and holonymy relationships. This incompleteness explains the low observed performances but does not affect the relative comparison of performances on real and gibberish corpora. Overall, the paper concludes that off-the-shelf LLMs are not sufficiently suitable for ontology learning tasks, particularly in the case of relation extraction, and that further research is needed to improve their adaptability to different domains. Here is a combined summary of pages 13 and 14 of the research paper. The authors investigate whether large language models, LLMs, can adapt to new domains from an ontology learning perspective. They conduct experiments on taxonomy discovery and relation extraction tasks, comparing the performance of various LLMs on real and gibberish corpora. The results, presented in Tables 3 and 4, show a significant performance drop when LLMs are tested on unseen words, indicating that they do not reason over semantic relationships. The attention mechanism relies heavily on lexical sense and token frames, rather than leveraging semantic relationships between tokens. This limitation hinders LLM's ability to perform ontology learning in arbitrary domains, where hypernymy relationships must be retrieved for unknown concepts. The authors further analyze the alignment results in Tables 4 and 5, which demonstrate the low F1 scores of LLMs in both tasks. This suggests that LLMs do not adapt to new domains and are limited to entities and concepts they have been trained on. To improve the performance of LLMs, the authors conduct a fine-tuning experiment, using instruction tuning specifically tailored towards taxonomy discovery. The training details are presented in Table 6, and the results are reported in Table 7. The fine-tuning experiment shows that task-specific performance improves drastically, regardless of the domain and corpus version. For instance, the F1 score of Falcon 7B improves up to almost threefold on the real WN music dataset. Although not surprising for real corpora, the improvement on gibberish corpora is non-trivial, indicating that LLMs can adapt to some extent. Overall, the study highlights the limitations of off-the-shelf LLMs in ontology learning tasks on arbitrary domains and demonstrates the importance of fine-tuning for improving their performance. Here is a combined summary of pages 15 and 16 of the research paper. The authors investigate the adaptability of large language models, LLMs, to arbitrary domains from an ontology learning perspective. They create gibberish datasets based on real data and real domains from WordNet and use LLMs to perform ontology learning tasks on these datasets. The results, presented in Table 7, show that LLMs do not adapt well to arbitrary domains, relying heavily on priorly learned semantics, lexical senses, and the frame of the tokens. However, after fine-tuning on gibberish data, LLMs improve at discovering hierarchies, both on the domain they were trained on and other arbitrary domains. The authors attribute this improvement to the emergence of reasoning with lexical semantics. They propose an experiment to test the transfer learning capabilities of LLMs, where they use Zephyr 7b beta, trained for taxonomy discovery in a domain, and tested on another domain using only gibberish corpora. The results, presented in Figure 3, show that the F1 scores generally tend to increase after transfer, with the exception of the WN music to WN suites case. The increase in F1 score is substantial, ranging from 14% to 32%. This result suggests that LLMs can perform ontology learning on arbitrary domains with effective pre-training. The authors also observe that fine-tuning makes the LLM more sensitive to syntactic clues of hypernymy relations at the cost of making them less precise. They conclude that LLMs do not adapt well to arbitrary domains, but can improve at discovering hierarchies after fine-tuning on gibberish data. This improvement is attributed to the emergence of reasoning with lexical semantics. The authors hope that their work can inspire future research to leverage reasoning with LLMs for ontology learning. Here is a combined summary of pages 17 and 18 of the research paper. The paper explores the concept of ontology learning in the context of large language models, LLMs. The authors investigate whether LLMs can adapt to specific domains and tasks, and if so, how this adaptation can be achieved. They provide an overview of existing research on LLMs, highlighting their capabilities and limitations in terms of domain adaptation. The authors cite various studies that demonstrate the ability of LLMs to learn from large datasets and adapt to new tasks and domains. For example, Falcon 40B, a large language model, has been shown to achieve state-of-the-art performance on various natural language processing tasks. Similarly, other studies have demonstrated the effectiveness of LLMs in adapting to specific domains, such as biomedical terminology and common sense knowledge. However, the authors also highlight the limitations of LLMs in terms of domain adaptation. They note that LLMs often rely on pre-training corpora, which may not be representative of the target domain. This can lead to a lack of domain-specific knowledge and a reliance on general language understanding. To address these limitations, the authors propose an ontology learning approach, which involves using LLMs to learn domain-specific knowledge and adapt to new tasks and domains. They cite various studies that have demonstrated the effectiveness of this approach, including the use of LLMs for ontology matching and alignment. The authors also discuss the importance of evaluating the performance of LLMs in domain adaptation tasks. They highlight the need for standardized evaluation benchmarks and metrics to assess the ability of LLMs to adapt to new domains and tasks. Overall, the paper provides a comprehensive overview of the current state of research on LLMs and domain adaptation, highlighting both the capabilities and limitations of these models. The authors propose an ontology learning approach as a promising direction for future research, and emphasize the need for standardized evaluation methods to assess the performance of LLMs in domain adaptation tasks. The research on large language models, LLMs, has been extensively explored in various domains. From an ontology learning perspective, studies have shown that LLMs can adapt to different domains by developing emergent abilities. For instance, chain-of-thought prompting has been found to elicit reasoning in LLMs, while symbol tuning improves in-context learning. Larger language models have also been observed to perform in-context learning differently. These findings suggest that LLMs can leverage domain-specific knowledge to enhance their performance. However, it is crucial to consider the limitations and assumptions of these models, such as their reliance on large datasets and potential biases. Future work should focus on further understanding how LLMs adapt and how their abilities can be leveraged for real-world applications.